Okay, let's use this simulation that Wolfram has for several distributions. We're going to keep using this for other examples, but now let's see what the binomial distribution could look like and see the impact of the value of n and the value of p. Remember that n stands for the number of trials of the number of experiments that you are doing, and then P stands for the probability of success. This is the mass function, the density function. No, this is actually the probability of getting 3 successes if you have these parameters 40 trials and then 0.1. And this is the cumulative. If you remember, the cumulative is always going to add 1. Most of the times is this if this n is large and this p is small, these numbers, the probability starts getting really close to 1. No? So that's why you can see here that in 14 this is just 1. It's not 1, but it's really close to 1. So for example, if you talk about the coin that you have the probability of success as 0.5, you can see here how this distribution is symmetric. No, those bars stands for the probability of getting 20, for example, heads. No, 20 out of 40, actually half. So this is the mean. You stand here for the mean. Remember that the mean is just n times p. Now, so you have here 20. If you start decreasing the probability, so you are going to have more probability to get 0 successes, and then 1, 2, 3, 4, 5, and then a little probability here for higher values, because the probability of one success is actually quite low. The other possible outcome is to have really high probabilities. Then the distribution moves to the right because you have high probability of success. So you are going to have large probabilities for higher numbers. Of course, there's an impact in the with the value of n, but actually it's more with the value of p. No, the mean is going to change. You have here the mean, also the variance. If you want to see, if you have large n and you have then, for example, small p, you can see the variance. If you start increasing the value of p, you are going to have an increase in the variance. Now we want low variance, but sometimes you just get a high variance because there are so many values. No, the variance, you can measure the variance here with the size of the graph. If you have small variance, for example here, it's because most of the points or most of the probability, it's just between, for example here, between 0 and 8. Now you have really low values here. But in the case when the variance starts increasing, for example in this point, you have several bars here. Now you can always draw the graph to see how the distributions look like, but here you have a good example and you can just play a little bit to see how the distribution looks when you change n or p.